In many cases, you can't actually do the prescribed method by measuring over one, up one, because the values are maybe unknown. Like in this case, we don't actually know the exact location of the vertex, or perhaps they go by decimal values and they're not easy to measure the over one, up, whatever. So in a situation like this would be one of them. You have to do a little bit different approach where we plug in a point value. So we're going to set this equation up, and your options from a graph are either to put it in vertex form or factored form. And because we don't actually know the vertex, we're going to write this in factored form. And R1 and R2 are the roots, and the minus is part of the formula here. So if we write this, A is unknown to us, X minus 2 is the first, and X minus 8 is the second. Now we have most of the equation with the exception of the A value. And we're going to use this additional point that we know the y-intercept, and really it could be any other point that we knew. If we happen to know some random position somewhere down the line, we could use that. But since this is a nice easy number and it's provided, we're going to use this 0, 2 in the equation. So the parabola does pass through that point, meaning that it is one of the points that occurs along this. We're going to substitute x is 0 into both x's and y is 2, and then solve for the a value. So in one particular instance, y will be 2, a is unknown, 0 minus 2 is negative 2, and 0 minus 8, negative 8. Solving for a, that would be a positive then, times positive 16. A little bit strange to have maybe your coefficient behind the unknown. So if we rearrange it in front, it's the same thing. 16a divided by 16, 2 over 16, or reduced 1/8 equals a. So let's go back and plug it in. The equation for this in 1/16 is the a value. That should right up front. And then x minus 2, that's the same. X minus 8. We'll go back to our variables x and y, but now we have determined what the vertical shrink in this case, because it's less than 1. The decimal value, of course, we wrote 16, and I had reduced it to 1/8. So let's fix that. Okay, 1/8 is the a value. Now from there, if we wanted to convert it into standard form, do not distribute this 1/8 into the equation. I find generally it's better to start with the box method with the double parentheses. We can write that x minus 2, x minus 8, this would be x squared, 16, so that's x squared minus 10x. That is the double parenthesis, but then there's still this 1/8 that I ignored for time being. That is in front. Now it is safer. Generally, students make fewer mistakes if they wait to distribute that. If you instead want to do it first, you would only do it into the first parenthesis, not into both parentheses. However, if you just wait till later, the numbers are going to work out a little better anyway. So this is going to multiply, distribute to all of those individual parts here. We get a is 1/8 x squared. B is 10/8, and we can reduce that if we wanted to. And then C is 2. So if your goal is just to write any equation, then we can stop at the factored form. If for some reason the goal is to convert it into standard form, then we have to do the box method and distribution to achieve that. Okay, example 2, we have only the vertex and some random point over here 2, and this should be 16.5. So that is located on the parabola. We know if we plug that in, it'll work out. Let's set this up here in the vertex form. is a x minus h squared plus k. And our h value is negative. So if you plug this in, it would be x minus negative 4. So that becomes positive. And then plus negative 6. So that's plugging it in. Technically looks like that. We can of course simplify it a little bit, make it look better so we can work with it easier. It's 4 squared minus 6 is the parabola that we know thus far. Now that would have a normal step of over 1 up 1, but this is doing something else. It's really unclear what's happening here. And even here the root is not exactly on 1, it's somewhere close by. So the fail-safe here, we don't have the y-intercept. We instead have some random point later in the parabola. And so let's use that. The x is 2 and the y is 16.5, and we'll substitute those into the equation as we know it thus far and simplify a little bit. Okay, so let's see, if we add this together, that of course is 6, and that makes 36, so 16.5 equals 36, and I'm going to write that in front of the a. That coefficient is multiplying the a. If I write it behind it, sometimes this minus 6 can run into trouble with interpreting that. So write it this way. There's no question about how to interpret it. Add 6 to both sides here. So we've got 22.5 equals 36a. And divide by 36. 22.5 over 36 is a. And that one, you could leave it as that. It is a little strange to have a decimal inside of a fraction. And so to essentially make it look better, we can multiply, we can scale both of these numbers up by 2, and that will make this a whole number and no longer a decimal. So this is equivalent to, let's see here, we have 45 on top, and then 3672 on bottom. And that is a little bit nicer of a fraction if later we had to do something with it. Let's plug that back into the original equation, substitute the, from here, we had the best looking equation without the a known to us, so we'll replace that. 45 over 72. And okay, that's not friendly. We wouldn't have been able to figure out that out with using the slope of that first major point. So this is an alternate method that's going to work more frequently.